First, you put your mirror in the middle of the cardboard with the graph paper underneath, holding it up with a piece of wood, and trace the back of it like so. Then we're going to put down one pin. This is going to be our object pin. So we're going to circle the hole in the graph paper and we'll call that object. This is where all of the light rays are coming from. So we're going to leave this pin here the whole time. Now we're going to find a light ray that's coming from our object. Notice we haven't moved the object, so it can be anywhere along here. We're just going to pick a random place. How about here? Notice it's between the pin and the mirror, and it's not along the line perpendicular. So we're going to label this one as an incident light ray. We'll call it I1. Okay, and you'll see in a second how this helps us find the incident light ray. Now we're going to locate a reflected ray, and the way that we do that is we line up the two pins in the mirror. So the two pins that you're seeing are the object pin and the pin that lets us trace the incident ray, and we line them up. And you can see it a little better in the next one, but if you can see in this one, all three pins are lining up in the mirror. So now, as you might have guessed, we're going to call this R1 for reflected light ray 1. So we'll circle it and call it R1. And this is going to let us find the incident and reflected ray. Now you're going to take the pins out, put them on the side so they don't get lost. Notice you don't take your object pin out, it stays there. You only take the two out that you will use to trace the light rays. The object pin stays where it was. Now you take one of your other pins and we're going to find another light ray. This is going to give us our incident beam. And now we're going to call that one I2. So circle the hole in the graph paper and call it I2 for incident light ray 2. Now we want to find the reflected ray, and this time we're going to have a little bit better view. You can see the two pins lining up in the mirror. Those are our object pin and our incident light ray pin, and we're going to line those up and put the third pin right in front of where those two appear in the mirror. So now it looks like we have three in a row. So we have all three in a row. That one is blocking the other two. Now you want to put yours on the graph paper like I just magically did there in the cut. And so now we're going to label this one as R2 for reflected light ray 2. So we lined them all up in the mirror. We're going to circle this and call it R2. Reflected light ray 2. R2. Okay. That's a 2, not a 1. Now we have everything we need to trace two light rays. So we kind of skipped the first one. Here's the second one. Take the pins out, set them to the side. Don't lose the pins. And we're going to trace from the object through the first pinhole to the mirror. That's going to give us our incident light ray. Put some arrows on there showing which way the light's going. It's coming from our object towards the mirror before it bounces off, and it's going to come through that spot. Don't lose the pin. Put it over there. Don't lose the pins. Now we're going to trace from the mirror through R2. Again, this is for our second light ray. Now the light ray is coming from the mirror through R2. So my pencil's going the wrong way. But we're going to put arrows on it so we know which way the light's moving. It's moving from the object, hits the mirror, bounces off, and goes through the point R2. Now the next step is to find the normal line, and this is a little trick to draw a 90-degree angle from the surface of the mirror. You use your crosshairs there and line them up like that, and the straight edge now gives us a line perpendicular to or normal to the surface of the mirror. So we draw that on there like that, and we're always going to measure our incident angle and our reflected angle from the line normal to the mirror. Again, normal just means perpendicular. So that line's at a 90-degree angle from the mirror. Now we're going to measure our incident angle. This is the angle that the light ray came in at with respect to the normal line. So we're going to measure that. It's going to be a little bit more than 30 degrees. We'll call it 30.5. degrees. And we'll do the same thing with our reflected light ray. We'll measure that. Notice that you line up the 0 on the normal line. You put the crosshairs on the vertex of your angle. And we'll measure this one. Looks like it's a little bit less than 30 degrees. I should have written one more figure here. I should have maybe called it 27.5 instead of 27, but that's okay. Remember to use the appropriate level precision. And now what we're going to do is we're going to take our reflected light rays and we're going to actually extend them back behind the mirror. So we have an extension of our reflected light rays back behind our mirror, and we're going to represent this with a dotted line. So we extend them behind the mirror with a dotted line. Do the same thing with both light rays, both reflected light rays, I should say. Extend them back behind the mirror. Draw a dotted line there to represent the extension of your reflected light ray, not the incident one. And wherever they cross, we're going to call our image position, okay? And then we're going to measure, this is the object, we'll call this distance here the object position distance, or the object distance. That's the object distance. It's just the straight line, the shortest straight line from our object to the mirror. And we'll do the same thing with our image distance. So this is the distance from the mirror, shortest distance from the mirror to where those extended light rays cross, and we call that the image distance. image distance. So again, from the mirror to where our extended reflected rays cross behind the mirror, that's the image distance. Now we're going to measure all